You may have heard when people say that water and oil do not mix together. So when they are describing two people who don't get along really well, they'll be like, they mix like water and oil. So by this, you know that water and oil do not mix together. But have you ever wondered why? So in this activity today, we are going to learn why water and oil do not mix together, and we can try to make the impossible happen. That is, try to make and mix water and oil together. So I have a beaker with me, and there is water in it, and I fill the beaker with water. And for today's activity, we will need beaker, water, dish soap, and oil. So before we get started, I'll just introduce myself. So my name is Payal, and I'm currently a master's candidate in biomedical engineering in Sheridan's lab at McMaster University, and my background is in biotechnology engineering. So I'll just get started now. So as I've mentioned, water and oil do not mix together. So in order to do the experiment today, I'm taking a beaker and I've filled it halfway with water. So I'm going to take oil. So you can use any oil of your choice. Right now I'm using a vegetable oil, and I'm trying to pour a little amount of oil to the beaker. So now I have beaker and then there is oil in it. I'm trying to mix it as much as possible. As you can see, no matter how much hard I try, the water and oil do not mix together. The oil is on the surface, on the top surface of the water, and no matter how hard I try to mix, they will never mix together. There are different substances such as fruit juices, food dyes, salts, sugars, etc., that get dissolved in water. But as you can see, the oil is not mixing in the water. This is because of the various properties of water and oil. So let us first understand the properties of water. I just want to make sure that you guys can see the top surface is the oil and the below is the water. So the oil is now floating on the surface of water. I've tried mixing it a lot of times, but it's still not mixed. It's still not mixing up. So as I've said, it is because of the properties of water and oil. So coming to the properties of water, the water has a very simple chemical structure. That is, it consists of two hydrogen atoms and one oxygen atom. So it is attributed to the polarity of water. Polarity is a very fancy word wherein we're describing the different charges that are present on the molecule. So water has a positive charge from hydrogen atoms and a negative charge from the oxygen atom. So when we have a water molecule, it tries to strongly bond to other water molecules, and it will not want to mix it with oil. So the water forms strong bonds with other water molecules rather than forming bonds with oil. The same goes with oil. The oil is non-polar in nature. So what is non-polar? It means that it will only form bonds with other oil molecules. That is, the oil is hydrophobic. Phobia means fear. So oil is water fearing. It hates water. So no matter how hard you try to mix, the oil and water will not mix together. The oil will only form bonds with other oil molecules, and the water will form bonds with only other water molecules. So again, no matter how much I'm mixing it, the water and oil will never mix together. So how to make them mix together? For that, we can use something known as a surfactant. So for now, for today's experiment, the surfactant that I'm using is a dish soap. And surfactants are generally amphiphilic in nature. Amphiphiles are a very fancy word of saying that they can be both polar and non-polar. So, for example, you go to a party and there are two people in the party, and the two people are not friends with each other. So they are like water and oil. They will not talk to each other. They are not friends with each other. So they will not talk to each other. They are not friends with each other. But there is this third person, which is the dish soap, which is friends with both water and oil. So what happens if I'm adding the dish soap to the water and oil? So dish soap is a surfactant and it will break the surface tension between the water and oil. So I'm just going to keep the water and oil aside, and I'm using a same mixture, and the here it is water and the above is the oil. So this is a beaker with water and oil, and this is water, oil, and I'm going to add dish soap to it. Just a little bit of dish soap, and the dish soap is a surfactant. So when I'm trying to mix it, as you can see, the water, oil, and dish soap. So now, earlier there was water and oil, and the oil formed at the surface, and the water was at the bottom. But now, as you can see, the oil has dissolved inside. So now there is no more oil. So this is a very basic principle of water, oil, and dish soap. And now this is known as emulsion. Emulsion is a very fancy way of saying that the water and oil and the dish soap are dissolved together. So how does this work? So like I've said, the dish soap acts like a surfactant. It is amphiphilic in nature. It is friends with both water and oil. So now it has completely dissolved inside the oil, and the oil is completely dissolved. That means that the dish soap is acting as a surfactant where it is breaking the surface tension between the water and oil. So one of the conclusions that you can derive from this experiment of water and oil and water, oil, and dish soap is that when you're washing dishes which are very dirty and untidy and they're very greasy and oily, so when you're trying to wash dishes which are oily and greasy, you go to the you try to wash them with just some simple water, it will never wash it off. So when you're trying to wash dishes with just water, the dishes will still remain greasy and oily. This is because, as we now know, that water and oil do not mix together. But what if we use a dish soap to wash our dishes? When we use the dish soap dissolves the oil and clears out the oily and greasy stuff that are present on our plates, on our dishes, and when we try to wash with our dish soap, we get really nice and clean dishes. So this is one of the other conclusions that we can derive from washing our utensils that we see in our day-to-day life. The other conclusion that we can derive from this experiment is that we are now in a coronavirus pandemic, and right now the biggest public health advice is to wash your hands with soap for 20 seconds, and the same thing happens. It's the same principle of water, oil, and dish soap. So when we are trying to wash our hands only with water, the oily substances that are present on our hands, which we cannot see with our naked eye, when we are washing our hands, the oily substances remain on the hand, and when we are only washing it with the water, they will obviously not get washed away, because water and oil, as we know, they do not mix together. But when we are washing our hands with soap, what happens is that the soap takes out the oily substances, and now when we see this whole coronavirus in very vague term is a oily substance. So it has oily molecule or something. So it has a lipid outer membrane which is made up of oil. So just in very vague terms, we can think of coronaviruses as oil. So when we are washing our hands with just water, it will not help. So we have to always wash our hands with soap, as soap has the ability to dissolve all the of oily membranes that are present, thereby annihilating the coronavirus, that is thereby destroying the virus. So this is another example of water, oil and dish soap. This is a very simple experiment wherein I've just in summary that when we are trying to mix water and oil, they will not mix together, but when we add the same dish soap to water and oil, it will result in this clear mixture. That is, the oil will get dissolved and it will form very cloudy layer as well. So there is also one more thing we can do with this experiment, that is we can create a density tower. So a density is nothing but mass by volume. So just we can use we can throw stuff in this. So this is a metal this is a screw and it is made up of metal, and when I'm trying to throw this metal, it is very dense, so it will go, and as you can see, it will go and it will go and sit at the bottom. However, when I'm trying to throw a sponge, or when I'm trying to throw this sponge, it will go and sit on the top, as the sponge is less denser than oil, so it will sit on the top, whereas the screw will sit at the bottom. So you can try throwing different objects inside your water oil emulsion to create a density tower. You can use maple syrup, corn syrup, etc., and you can create a density tower. If you have any questions, please comment down below. I will also be available to answer them later. And this is just a simple basic experiment to show that water and oil, when we are trying to mix them together, they will not mix together, but when we are using a dish soap, it forms an emulsion, thereby mixing the water, oil and dish soap together, as the dish soap acts like a surfactant, thereby breaking down the surface tension between water and oil. And when we mix water and oil together, the oil always floats on the top, as the oil is less denser than water. So this is a very basic experiment. Also, you can try throwing different stuff in the water and oil and dish soap to see the density tower.